Hello. I haven't done anything Amos related for a while on the channel. I haven't done anything Amos related in general, but something piqued my interest over the weekend. I saw this. This is a screen grab from the 8-Bit Guy's video where he was testing a TI-99/4 against a Commodore PET, and he had a program which was a prime number calculator. And it occurred to me, I don't think I've ever coded that, and so wanted to give it a go. And it led me down quite the rabbit hole, and I thought I'd just share my findings. So this is, as you can see, the code, which the way this calculates is the, if you like, the brute force approach. What it will do is it will try every number up to a number, and if the integer of that number being divided matches its standard division without being integered, then it must be a prime number, because of course it has to be divided by itself only, or one. So I thought, well, I'll just type that in and we'll see how it works. So if I this is just my workbench. If I switch back, so this is the initial code. Now, I've gone through several revisions. Just some basic screen setup. I reset the system timer to 0. I set the number of primes to 1, and because of how I'm doing the maths, I'm not starting from 1, because you can't divide 1 by nothing, 1 by half, I suppose. So I'm printing 2, which is like a forced assumed first prime, and then I'm going from 2 to 1,000 steps of 1. Now this is literally the same, well, it's kind of the same as what the 8-Bit Guy did, in that you're checking every number up to the test number, and you can see it uses a flag to say it's not a prime yet. It goes through the loop, and if it's still not been triggered, if it's still not been said it's a prime, then print the number and add the number of primes to 1. Add the number of primes by 1, I should say. And then when it gets to the end, it prints the time it took and the number of primes it found. So this is how this runs, and look at the speed at which this runs. It's fairly fast, but you can see it's slowing down as it gets through the 1,000 digits. So it took 234 and it found 168 primes, which is correct. There are 168 primes in the first 1,000 digits of the numbers. So then I wanted to see if it could be optimized, and I've been playing about with ChatGPT lately, and ChatGPT is fairly good at working in Amos code, which is surprising. So I asked it, how can it be optimized? And it said, well, the first thing you can do is not check all the even numbers, because you got to rule them out anyway. So it told me about doing step 2, and because of how we're jumping in steps of 2, and because of another optimization, we actually start the loop of numbers from 5. So we assume 2 and 3 are the first 2 primes, and we set our prime count to 2 to begin with. Otherwise, it's pretty much the same. Reset the time to 0, set up all the screen and usual, and then we instead of searching from the start number, in this case 3, to n, which is the main number we're checking up to, we check from the integer of the square root. Now this plus 1, this took me about an hour, 2 hours maybe to figure out. What it was doing was it was reporting the wrong number of primes. It would say, oh, there's 181 primes in the first 1,000 numbers, and we know it's 168. So I started asking it different ways, like, why is it giving me 181? And it said, oh, it's because you've done this, and I hadn't. Or it'll say, oh, you haven't done this, and I had. In fact, at one point I just copy pasted its code back in, and it still gave 181. And it's, in the end, it says, oh, you're never quite checking the last number, because of how you say it's the integer of this divided by this, which means it's being rounded down in some instances. So I said, well, can't we just add 1 to the number that we're checking? And it went, that's a brilliant idea. I hadn't considered that. And that threw me, because the AI hadn't considered the actual solution. And it said, oh, you can do this, and it simplifies what you're doing without rewriting all the code base and putting in other checks. So we do the integer of the square of n plus 1 in steps of 2, and the rest of the code is the same. It prints all the numbers out as it finds them, it adds 1 to the number of primes count, and then it prints the time it took. Now the last one was, what did we say for that? If we just run the other code again, this was I think 143, something like that. Time 237. So that's how long it took to brute force it. Now if we run the optimized version of that code, which is, remember, in steps of 2, and it's only checking to the square root of n, a bit quicker, 3 instead of 273 or 237. Still found the same number of primes. The list is accurate. So then, I mean, I was pleased with myself at that point. I thought, you know, job well done. And I thought, well, let's ask it if there's a completely different approach, a way of tackling finding prime numbers that doesn't involve just dividing numbers against their integer division and see if they match. And it said, yeah, you can use the sieve, which it's the sieve of Eratosthenes, which I've never heard of before. But you essentially sieve numbers rather than dividing them. So this, it has a similar setup. It uses a dimensional array, which became a problem, but it's creates 1,000 array. It puts a 1 in each one, and then it does the maths, and if it gets the result it expects, it puts a 0 in, so it casts it out of the list, and then it goes through and it counts up the number of ones that are left. So this is a completely different approach. There's no division against integers, and again this just goes bang, time 168 primes, and so that's getting really fast now. But obviously it's only 1,000 numbers, so I set it to 2,000, and it took a little longer, but it was very fast. I set it to 3,000 and I ran out of memory. So Amos said, oh, you've not got enough variable RAM. So I said to ChatGPT, because obviously I explored, like, can I just add more RAM and edit the emulator, and I wasn't getting anywhere with that. So I then said, well, how about if we just use the screen space as the array? So instead of using dim and then setting variable, array variables, we just plot to the screen a white dot or a black dot, and we read the color of the dot on the screen at that position. And it said, oh, that's fantastic, that's great, that's that means you don't run out of chip RAM. And that caught me off guard, because the fact that ChatGPT would know that the variables in Amospro are stored in chip RAM is an interesting thing that it might know. But it says, plus it means you've got like 150,000 pixels in your array now, so you can have any old number you want. So we worked on a revised chunk of code. So what this does here is this is now set to use not just 1,000 numbers, but 281,600 numbers. If I actually set this to 1,000 numbers, just so you can see how fast it deploys this, it sets the screen up again. It puts all the ones in the array, as it were. Then it does the same maths, but it's doing it based on an XY coordinate, and it's using the mod 640 divide by 640 approach, which is brilliant, because if you divide it by 640 you get the vertical lines, and if you mod 640 it, you get the X position wrap around over and over and over. At the end of that, it then goes through and says count up all the dots and add 1 to the number of primes that it's got, and then give us the answer. So this, it will draw it to screen and give us the text on screen. So this is for 1,000 numbers, remember, and that's it. It's 2 rows on screen. 168 time 1 again, and it's because we're dealing with such small numbers of digits. It's the time becomes immeasurable. But if we change that back to 281,600, 281,600. So this is most of the screen, and this is how fast it calculates 281,500 primes. So that's it, cycling through and removing out the numbers that are primes of base primes. It took 413, and there's 24,564 primes in the first 281,600 digits, which is insane. It absolutely caught me off guard that ChatGPT was able to work through it. The only stumbling block, which I really had to sort of force it to do, was this +1. It hadn't recommended it in any of its fixes, where it was a case of why is the number of primes it's reporting higher than the actual number, because the flag wasn't being triggered because it hadn't got to the last number in the sequence, and it only needed an extra 1 in the sequence to be able to achieve it, because sometimes that gets rounded down when it's step 2's over it, but then square roots it back down. So yeah, there you go. It's quite crazy to think that you can do. I mean, I was doing like 10,000 digits at one point, and it was quicker to run this program than it was to ask ChatGPT how many primes there are in 10,000 digits. So yeah, it's mad. And to watch it actually produce the image is quite interesting. It's depending on the X and Y widths that you give it, you can get some quite interesting patterns develop as it runs. But there you go. Right, finish again. So you can see certain patterns occurring in it, and now it's scanning the screen and counting up all the dots. There you go. Hope you found that interesting. It interested me, certainly as a using ChatGPT to solve coding problems, but also as far as the optimizing and this sieving approach of erratus themes was a completely different take on the problem. So yeah, there you go. Anyway, interesting. Cheers. Bye.